All right, Mr. Ahmed here for 2.4. Our goal for today is algebraic reasoning, and we are going to write algebraic proofs. Before we start with some algebraic proofs, we're going to talk about some properties that you've used in Algebra 1 and that you know, but really haven't put a name to them. And the first one's called the addition property of equality, which really just tells us that we can add something to both sides of an equation. So we started the equation if A equals B, I can add something to both sides. So if I add C to one side, I'd have to add C to the other side. Same type of process with the subtraction property of equality. If I subtract something from one side, I would have to subtract it from the other. So you did this quite a bit while you were solving equations last year. And really what we're doing right now is we're putting the actual property a name to it. Okay, multiplication property of equality states that we can multiply something to both sides of the equation. So in this case, we multiplied C to both sides. We started with A equals B, we took A times C. Other side, we took B times C. In a similar manner, we can also divide by something on both sides. I can divide by C, divide by C. I can't divide by 0. So I'm going to add that in. C cannot equal 0. All right, you can't divide by 0, first commandment of math. The distributive property states that we can distribute. So if I see something outside the parentheses, we would distribute the A to both the B and the C, A times B plus A times C. And we could also do it over a minus sign as well. So we've done all these properties, we're just attaching the names. Addition property of equality, subtraction property of equality, multiplication, division, distributive properties not of equality, because I'm not doing it to both sides of an equation. I'm just doing it as a simplifying piece. And substitution states if A equals B, then B can be substituted in for A and vice versa. A could be substituted in for B. All right, so I can substitute something in. Last thing I will state is a lot of times I will abbreviate this P property of equality as a POE rather than just writing out property of equality over and over and over again. So POE and POE, POE, and POE. So what we're going to do is we're going to start the process of writing a two-column proof. All right, that's really our goal. We're taking something you've done before and something that's familiar to get us started on this process of writing proofs. And for us to prove something in math, every step that we make has to be justified. And we justify things by either using definitions, theorems, properties of equality, and just all the mathematical properties that we know are true. All right, so we have to justify each step. So what we're going to do here is we're going to look at this equation, 3x plus 2 equals 23 minus 4x, and we're going to prove that the solution is x equals 3. So on that way for that process, we're just going to list all the reasons that we used to solve it. So the first reason is always starting with what we know. We were given an equation, we wrote down that equation. That is a given piece of information, something that was given to us. The next step to solve, it appears as if we added a 4x to both sides. So if I add a 4x to both sides, that's bringing this x over for me to round up the x's. That's the purpose of adding the 4x. If I add something to both sides, I'm using the addition property of equality. The next step, we went from here to here. And in order for us to move here, we combined like terms. 3x and 4x added up to 7x. Negative 4x and 4x canceled off and gave us just a 23. So for us to move from step 2 to step 3, we combined like terms. You could also say combine like terms. Simplify. I don't care. You're going to see that used numerous ways. So you might state that it was simplifying or it was combining like terms. Next step to solve, we would subtract 2 from both sides. So we're going to bring that 2 over. So we subtracted 2, subtracted 2. If I do it to one side, I had to do it to the other. So we use the subtraction property of equality. And then again, combined like terms. We took 23 minus 2 to get 21. 2 minus 2 is 0, so it's just 7x. And finally, the last step would be to divide both sides by 7, so we're using the division property of equality to finish. So we justified every step along the way. Like I said, we know how to solve equations. The reason why we're doing this is to help us practice the process of writing a proof with something we already know how to do, which is solve an equation. So, a couple other properties. The reflexive property states, and these are of equality. So this is the reflexive property of equality because it's an equal sign. We will also have properties of congruence when we use a congruent sign. So the reflexive property states that something is equal to itself. So for instance, A is equal to A, 7 is equal to 7, and we will have segment lengths that are equal to themselves. All right. The symmetric property states I can flip the order of something. If A is equal to B, then B is equal to A. We can switch the order. And these are all with equal signs. And the transitive property, this is probably a big one. It's kind of like substitution. All right. I could state that this is substitution because these are equal signs, but if it's a congruent sign, I can't. So that's good reason for us to recognize the transitive property. And it states if A is equal to B and B is equal to C. Notice, A is equal to the same thing as C. Thus, A also would have to be equal to C because they're equal to the same thing. So we can write our newest statement and say A is equal to C. So we're going to have to recognize these properties. We will also use them. This was property of equality because it was an equal sign. So state the property used. So we started, if the measure of angle 6 is equal to the measure of angle 7, then the measure of 7 was equal to 6. Which property was used? Well, I see that we switched the order. 6 came first, then 7 came first. The one where it switches the order is the symmetric property of equality. Next one says something's equal to itself. Equal to itself, reflexive, one item. That's one way I remember these. The reflexive property, we have one item. Symmetric property, we have two. We switch the order of the two that are equal. And finally, the transitive property has three items that are all equal. Okay. So the next one says measure angle 1 equals measure angle 2. 2 is equal to 5. So 2 is in common for both. So since 2 is equal to 1 and 2 is equal to 5, then 1 would also have to equal 5 by the transitive property of equality. So you will have to recognize those. Some more examples here. Taking a look at solving, and we are going to recognize the steps. So step 1, 3x plus 12 equals 8x minus 18. Where did that come from? That was given to us. So step 1 typically in a proof is going to be a given. Step number 2, what did we do next? Well, it appears as if our 3x vanished from this side. For us to move the 3x, we would have had to have subtracted 3x. So we used the subtraction property of equality. Now what happened here? Our 18 moved. Our 18's gone. To move a negative 18, we would have had to have added. So we had the addition property of equality. We added 18 to both sides. 12 plus 18 is 30. And then we divide by 5. So we're using division. Property of equality. And finally, notice we switched the order because we were supposed to end with x equals 6. We can't end with 6 equals x. Need to end with the statement that we are proving. So for us to flip that around, we are using the symmetric property of equality. Switch the order. We have to end with exactly what we're proving. And we're going to do two more. Statements, reasons, justify each step. I will number each step. So step 1, start with what we know. We know that 5x minus 10 is equal to negative 40. That is given. Notice I number both sides. Step 1 is given. Step number 2, for me to solve. First thing I'm going to do is I'm going to add 10. Now, I'm not going to show that I'm adding 10. I'm going to do that in my head. Plus 10 cancels. Plus 10 gets us negative 30. We added 10. So we use the addition property of equality. Next step is to divide. So we're going to divide by 5, and x is equal to negative 6. So we use the division property of equality, and notice our ending statement, x equals negative 6, is exactly what we were proving. We have to end with exactly the same thing, which we did. So our next one, we have to end with x equals 1. Okay? So, our next process. Start with what we know. Step number 1, 3 times 5x plus 1 equals 13x plus 5, given. Step number 2, I'm going to distribute 15x plus 3 equals 13x plus 5. Use the distributive property, that's not of equality. Just a property. Now, here we got some choices. All right, you can move the 3, you can move the 13x, you can move the 15x. For the sake of this problem, I'm going to move 15x. So I'm going to subtract 15x from both sides. Now, if you subtracted 13x, would that be incorrect? Absolutely not. Choice is yours. Okay, so I'm going to subtract 15x. So I got 3 equals negative 2x plus 5. I subtracted 15x from both sides. Property of equality. So next step for me is going to be to subtract 5 from both sides. So I would get negative 2 equals negative 2x. Subtraction again. And lastly, I'm going to divide. And I get 1 equals x. Use the division. Property of equality. So, is this what we were supposed to end with? Not quite. X is supposed to come first. I got to switch the order. So I'm going to use the symmetric property to state that x is equal to 1. So I had to make one extra step the way I did it. Property of equality. Flip the order. So that's it for today. Have a good one.